we've talked briefly about the concept of analogues, in that heroin is an analogue of morphine, and that atropine, for instance, is also an analogue of morphine. So here's desomorphine. It's made from morphine, it's more potent than morphine, but it's not readily available to illegal users. On the other hand, here's codeine. Codeine may be made from morphine, or it may be extracted directly from opium. And codeine in most countries is relatively easy to obtain because it's used in cold medicines. It's nowhere near as active as morphine, and so in many countries, codeine-containing medicines are available over the counter. You can convert codeine to desomorphine. You need to remove one carbon atom and one oxygen atom and add a few hydrogen atoms. One way to do this is a recipe that's available on the street, which is to treat codeine with iodine, red phosphorus, hydrochloric acid, and a solvent such as gasoline or oil. Now, iodine, of course, you can easily get from pharmacist's shop because iodine is used as a disinfectant for wounds. Red phosphorus you can obtain because it's present in the heads of matches, so you can scratch it off the match heads and use that. And hydrochloric acid can also be obtained. So, in some countries, particularly Russia, drug addicts are taking codeine-containing medicines, cooking them up with this appalling brew here to make something very potent because it contains desomorphine. In Russia, this is known as crocodile. The reason it's called crocodile is that when it is injected into a vein, it causes enormous damage to the tissues. The damage is probably not caused by the desomorphine, but is caused by all the other chemicals and byproducts that are produced in this reaction. The skin becomes hard and scaly, like the skin of a crocodile, hence the name crocodile. There are apparently many users in Russia. It's extraordinarily addictive, and once people start taking crocodile, they will take it continuously until perhaps they run out of iodine or red phosphorus or cough mixture. Most disturbingly, crocodile now seems to be spreading to other countries around the world, including the United States. Now let's look at analogues. Here again is the structure of diamorphine, which, as you know, is an analogue of the natural compound morphine. Diamorphine is illegal. Now look at this compound here. That's not diamorphine. It has one extra carbon atom, so chemically and legally it is not diamorphine. But it would be just as effective as diamorphine because the two ester groups that have been added would be cleaved off in vivo and morphine would be released and have its normal effect. So if you make diamorphine illegal and you specifically say diamorphine is illegal, diamorphine is diacetylmorphine, this chemical here, just as effective, would not be covered by that legal definition. How can we deal with this issue? In principle, illegal chemical laboratories could modify drug molecules in very simple ways to avoid the law. So as long as these illegal laboratories stay ahead of the law, then these so-called designer drugs are perfectly legal. What are the solutions? One solution is to control specific compounds as they become a problem. When the drug control agencies find these compounds on the street, then they can go back to the lawyers and the politicians and have them made illegal. that, of course, takes time. You could control particular classes of compound. So instead of saying a compound is illegal, you could say all compounds in this class are illegal. So in the case of heroin, diamorphine, all esters of morphine were made illegal in most countries many, many years ago. Ban the whole class. The danger of this is that in banning the whole class, you may actually be banning something in there that is useful. So as you saw, some countries maintain exceptions. The UK, for instance, still allows heroin in very specific situations. The other possibility is to pass a law specifically banning analogues. So you could pass a law saying this compound is illegal and all its analogues are illegal. The difficulty then is defining what is an analogue. In particular, you have to find a way to define analogues which is understandable by the legal profession. So what is understandable as an analogue by a medicinal chemist and by a judge in a court may be completely different things. For instance, dimethyltryptamine, DMT. It's a naturally occurring compound. In many countries, including the United States, it is illegal. What about DET, diethyltryptamine? It's a synthetic compound. It differs from DMT in the fact that it has 2 additional carbon atoms on the substituents on the nitrogen. Well, looking at the 2 structures here, I think any reasonable person would see they are very, very similar, and DET must indeed be an analog of DMT, and under the Federal Analog Act, DET would be just as illegal as DMT. What about this one? AET. And you can see it's very similar to DMT, but it's different because the atoms around the nitrogen are different. So AET, alpha-ethyltryptamine, is a synthetic compound. As an analog of DMT, is it illegal in the eyes of the law? Well, DMT is specifically controlled. DET, even though it is an analog, is also specifically controlled. What about AET? Is that controlled because it's an analog? Well, probably any medicinal chemist looking at the structure would say, yes, AET is an analog of DET. But when this went to district court, the court said, no, the structure is too different. In the eyes of the law, it's not an analog. And so that case was dismissed, but now AET is specifically controlled. So modern synthetic chemistry has given us lots of compounds with remarkable properties, and we've benefited from them in terms of the pharmaceuticals now available to us. But we pay the price because it also gives an opportunity to the makers and sellers of these illegal drugs.